Welcome to the Introduction to .NET. .NET is Microsoft's powerful cross-platform framework for building modern applications. It's more than a language. It's a complete development ecosystem. So let's begin our journey into .NET. What is .NET? .NET is a free, open-source, cross-platform development framework created by Microsoft. It gives developers a runtime environment, programming languages, libraries, and tools to build modern applications. You can use .NET to build web applications and APIs with ASP.NET Core, desktop apps with Windows Forms, WPF, MAUI, mobile apps with Xamarin/.NET MAUI, cloud and microservices with Azure, Docker, Kubernetes, gaming with Unity, uses C# with .NET, AI and machine learning with ML.NET. In short, .NET is not just a language, but a complete ecosystem for application development. Now, let's explore the key components that make up the .NET framework. CLR Common Language Runtime, CTS Common Type System, CLS Common Language Specification, BCL Base Class Library, FCL Framework Class Library, Garbage Collector GC, Assemblies and Intermediate Language IL, NuGet Package Manager. CLR Common Language Runtime. The heart of .NET, it is the execution engine. Responsibilities: converts intermediate language, IL, into native machine code using JIT compiler, manages memory with the garbage collector, ensures security, code verification, type safety, handles exceptions and threading. Without CLR, .NET applications cannot run. Purpose of CLR. 1. The execution engine of .NET. 2. Runs all .NET applications. 3. Provides services like memory management, security, and exception handling. Key responsibilities of CLR. 1. Code execution. 2. Converts IL, intermediate language, into native machine code via JIT compiler. 3. Memory management by using garbage collector, GC, to free unused memory automatically. 4. Exception handling provides structured error handling across .NET languages. 5. Security that enforces type safety, code verification, and CAS, code access security. 6. Thread management that manages multithreading and task scheduling. 3. Execution flow of CLR. First, source code, C#, F#, VB.NET. Then, compiler, creates IL code. Then, CLR loads, assembly. Then, JIT compiler creates native machine code. Then, CLR services, GC, security, exceptions, threads. 4. Benefits of CLR. First, 1. Platform independence. Runs IL on any supported OS. 2. Automatic memory management. 3. Enhanced application security. 4. Consistent runtime behavior. 5. Simplifies developer effort.
Now let's understand CTS, the Common Type System. 1. Defines how data types are declared, used, and stored in .NET. 2. Ensures that all .NET languages, C#, VB.NET, F#, share the same type system. For example, an int in C# equals system.int 32 in .NET. A string in C# equals system.string in .NET means you can write a class in C# and use it in VB.NET seamlessly. Purpose of CTS to ensures all .NET languages share the same type system 1. C#, VB.NET, F#, all compatible 2. Enables cross-language interoperability type categories of CTS. 1. Value types those stored directly on the stack. Examples, int, bool, char, struct, enum. 2. Reference types those stored on the heap. Reference held in stack. Examples, string, object, class, interface, array unified representation of CTS, where every data type maps to a .NET system type like C# int to system.int, 32 C# string to system.string, C# bool to system.boolean. Benefits of CTS1 cross-language compatibility. 2. A class written in C# can be reused in VB.NET or F#3. Type safety enforced by CLR 4. Reduces errors in type conversions 5. Provides consistent behavior across platforms. Now let's understand CLS, the Common Language Specification. CLS is a subset of rules all .NET languages must follow. CLS guarantees that code written in one language can be used in another. For example, if you create a public class in C#, VB.NET can also use it, provided you stick to CLS compliant features. What is CLS? 1. A set of rules and guidelines. 2. Ensures interoperability between .NET languages. 3. Defines what language features must be supported. Purpose of CLS. 1. Allows code written in one .NET language to be used in another without issues. 2. Promotes cross-language development. Example, CLS compliant code, public class sample, public in add in AE int B, or task A plus B, works in Siri, VB.NET, F#2. Non-CLS compliant code, public class sample, Yashuri, public uint, add, uint A, uint B, Bershur, a plus B, may not be usable in all .NET languages. VB.NET doesn't support uint. Key rules of CLS. 1. Only CLS compliant types should be exposed in public APIs. 2. Case sensitivity in identifiers is restricted. 3. No use of pointers in public interfaces. 4. Public members must use CLS compliant data types. Benefits of CLS. 1. Cross-language compatibility. 2. Better collaboration between teams using different .NET languages. 3rd, safer and more predictable APIs. Now, let's understand BCL, the base class library. BCL is a collection of fundamental classes and APIs. BCL provides ready-to-use functionality like 1. File handling, read, write files. 2. Collections, list, dictionary, stack. 3. Input, output, console, streams. 4. String manipulation. 5. Networking, HTTP client. 6. LINQ, language integrated query. In base class library, BCL, we have core system classes like system.object base of all types, system.string, text handling, system int32, system boolean, system double, primitive types. Then we have collections like system.collections, array list, hash table, system.collections.generic, list dictionary, system.collections.concurrent, thread safe collections. Then we have IO, input/output, like system.io.file, system.io.streamsystem.io.directory. Then we have networking, like system.net.http.http client, system.net.sockets. Then we have data and LINQ like system.data, basic data access, system.link, language integrated query. Then we have utilities like system.text, encoding string builder, system.diagnostics, debugging, tracing, system.threading, tasks, async, await. Then we have security like system.security.cryptography system.security.principal. Now let's understand FCL, the framework class library. That is superset of BCL, includes more advanced libraries. FCL provides support for ASP.NET web development, ADO.NET database access, Windows Forms and WPF, desktop UI, Entity Framework, ORM, ML.NET machine learning. Framework class library FCL contains base class library, BCL, foundation and data access. We have ADO.NET and entity framework. In web development, we have ASP.NET core and web API. In desktop development, we have Windows Forms, WPF and MAUI. In cloud and services, we have WCF legacy and gRPC and .NET. In AI and machine learning, we have ML.NET, and in utilities, we have diagnostics, configuration, and globalization. Now let's understand GC, the garbage collector. It is part of CLR, responsible for automatic memory management. It frees memory occupied by objects that are no longer in use. It uses generational collection. Gen 0 to short-lived objects, local variables. Generation 1, medium-lived objects. Gen 2, arrow long-lived objects, static objects, global data. Also, it helps prevent memory leaks and makes .NET applications more stable.
At first, we have object allocation. Means new objects are created on the managed heap, where we have generation 0, short-lived objects, for example, local variables. Generation 1, medium-lived objects. Generation 2, long-lived objects, for example, static objects. When memory pressure detected. When Gen 0 heap is full, then GC is triggered. Next, we have mark phase, where GC identifies all live, reachable objects. Roots, static variables, stack references, CPU registers. Any object not referenced equals to garbage. Next, we have sweep, compact phase. In that 1, unused objects are freed. 2, memory is reclaimed. 3, remaining objects are compacted to avoid fragmentation. In .NET, surviving objects are promoted through generations, Gen 0 to Gen 1 and Gen 1 to Gen 2. Objects with finalizers are cleaned up before memory is released. Once cleanup is done, execution resumes with freed memory, fully automatic, no manual management needed. Let's take a look at assemblies in .NET. An assembly is a compiled code unit in .NET, either a DLL or EXE. It contains intermediate language code along with metadata. At runtime, the CLR's JIT compiler converts this IL into native machine code for execution. Assemblies in .NET are compiled code units, created as either DLLs or EXEs. They contain intermediate language code, metadata, and a manifest that defines identity and references. There are three types of assemblies: private, shared in the global assembly cache, and satellite assemblies for localization. Assemblies provide benefits like encapsulation of code and resources, strong versioning, defined security boundaries, and flexible deployment. Intermediate language, or IL, is a set of CPU-independent instructions generated by compilers like C#, VB.NET, or F#. When executed, IL is loaded into the CLR, where the JIT compiler converts it into native machine code for the target operating system and CPU. IL provides cross-platform portability, language interoperability, and secure verifiable execution. For example, the simple C# statement int x equals 5 plus 3 translates into IL instructions like load 5, load 3, add, and store. Let's understand how .NET works. First, you write code in C#, VB.NET, or F#. The compiler then generates intermediate language code along with metadata. Next, an assembly is created, packaged as a DLL or EXE, containing IL metadata and a manifest. The CLR loads the assembly, and the JIT compiler converts IL into native machine code optimized for the OS and CPU. Finally, the native code runs on hardware, with garbage collection, security checks, and performance optimizations handled automatically. Now let's understand NuGet Package Manager. NuGet is the ecosystem of reusable libraries for .NET. Developers can easily download ready-to-use packages like Newtonsoft JSON or publish their own for others. It saves coding effort and promotes reusability across projects. What is NuGet? It's the official package manager for .NET, providing reusable libraries that help developers share, discover, and install packages. How does it work? A developer creates a library, publishes it to NuGet.org, and other developers can install it into their projects, with packages automatically restored during build. NuGet offers different types of packages. Official Microsoft packages like ASP.NET Core, Entity Framework, and ML.NET Community favorites, such as Notice.json, Authenticate, and Serolog, and even private custom packages for enterprise use. NuGet brings powerful benefits. It saves development time by eliminating the need to reinvent the wheel, promotes code reuse and sharing, simplifies dependency management, and provides seamless updates with version control. It even supports cross-platform development. For example, you can quickly install a package using the command .NET add package NuGet mote.json, and with .NET restore, the package is automatically restored. Now let's understand security in .NET. 1. Security is one of the biggest strengths of .NET. 2. Code access security. CAS that defines what code can or cannot do. For example, read files, access registry. 3. Role-based security that works with Windows or Active Directory to authenticate and authorize users. 4. Cryptography libraries, and that we have support for encryption, hashing SHA, AES, RSA, certificates, and JWT tokens. 5. Runtime security, where CLR ensures type safety, prevents buffer overflows, enforces memory safety. 6. ASP.NET Identity, a framework for managing users, roles, and authentication in web applications. 7. Data protection, which protects sensitive data like passwords, tokens, and cookies. 8. Web application security. ASP.NET Core has built-in defenses against XSS, CSRF, SQL injection. 9. With .NET, security is built in rather than an afterthought. .NET provides security across multiple layers. At the language level, it ensures type safety and memory safety, preventing buffer overflows. At runtime, the CLR performs code verification and enforces strict security boundaries. At the application level, authentication, authorization, and identity management protect users. Data security is achieved through encryption, hashing, and certificates. Web security includes built-in defenses against XSS, CSRF, and SQL injection. And finally, deployment security is reinforced through code signing, sandboxing, and secure updates. .NET comes with a rich set of security features. Code access security controls what assemblies can or cannot do. For example, preventing unauthorized code from reading files or modifying the registry. Role-based security works with Windows and Active Directory, assigning roles to users and enforcing access based on those roles. The cryptography APIs provide everything from hashing algorithms like SHA and HMCA to encryption methods such as AES and RSA, as well as digital signatures, X.509 certificates, and secure random number generation. SP.NET Identity goes further by managing users, passwords, and tokens. It supports modern authentication protocols like OAuth, OpenID Connect, and JWT, while also ensuring passwords are securely hashed and salted with algorithms like PBKDF2 or bcrypt. Finally, the Data Protection API safeguards sensitive data, protecting connection strings, authentication tokens, and cookies from exposure. .NET encourages secure development practices. Developers should always validate user input using model validation and data annotations. Use parameterized queries to prevent SQL injection attacks. Enable HTTPS and HSTS by default in ASP.NET Core for secure communication. Secrets, such as connection strings, should be stored safely using tools like Azure Key Vault or the .NET User Secrets Manager. And finally, keep applications secure with regular patching and NuGet package updates. .NET's built-in security features provide enterprise-grade protection. They help reduce the risk of common vulnerabilities, saving developers from writing complex, low-level security code. At the same time, .NET ensures compliance with modern security standards, making applications safer by design. Let's talk about performance in .NET. Modern .NET, from .NET Core to .NET 9, is built for speed and scalability. ASP.NET Core ranks among the fastest web frameworks in benchmarks. The NuGet compiler optimizes intermediate language into efficient native code, while ahead-of-time compilation improves startup times. Async and await let applications handle thousands of requests without blocking threads. Memory features like span and memory reduce allocations, and the garbage collector is optimized for low latency under heavy loads. With cross-gen and ready-to-run images, applications start faster and hardware intrinsics tap into CPU-level SIMD instructions for demanding workloads such as AI and scientific computing. In short, .NET is not just developer-friendly, it's also designed for high performance at scale. .NET includes powerful performance optimizations. The JIT compiler, NuGet, converts intermediate language into optimized native machine code and uses tiered compilation for fast startup, then further optimizes hot paths. Ahead-of-time compilation precompiles applications into native code, reducing startup latency, especially useful for mobile and cloud apps. Cross-gen and ready-to-run images also precompile assemblies, speeding up application startup on the first run. For memory efficiency, the garbage collector uses generational collection, optimized for server workloads, with low-latency modes for real-time applications. Features like span, memory, and array pool reduce unnecessary allocations, while value task minimizes overhead in async calls. All these together make .NET applications fast, efficient, and scalable. .NET provides modern concurrency and async programming models. With async and await, developers can build non-blocking I/O that efficiently handles thousands of requests. The task parallel library supports parallel loops, tasks, and continuations, while channels and pipelines enable high-performance data streaming, powering components like the Kestrel web server. On the web and cloud side, ASP.NET Core is consistently ranked among the fastest web frameworks in benchmarks, with Kestrel optimized for high throughput. For microservices, gRPC in .NET enables high-performance communication, and minimal APIs provide lightweight, faster endpoints for modern applications. .NET takes advantage of hardware and platform-level optimizations. With SIMD and hardware intrinsics, it uses CPU-level vectorized instructions for faster math, AI, and image processing. Native support for ARM64 and multiple platforms ensures optimized builds across Linux, macOS, Windows, and mobile. The tiered JIT compiler with profile-guided optimization learns application behavior at runtime and dynamically re-optimizes hot paths. For developers, powerful performance tools are built into the ecosystem. .NET Counters provides real-time performance metrics. .NET Trace captures low-overhead tracing. .NET GC Dump analyzes memory allocations, while PerfView and the Visual Studio Profiler deliver in-depth profiling and performance tuning. Together, these tools help developers diagnose, monitor, and optimize .NET applications with precision. .NET delivers clear performance benefits. It offers faster startup and execution with lower memory usage. Applications scale efficiently for demanding cloud workloads, and in some scenarios, .NET performance is even competitive with C++. This makes it an ideal choice for enterprise solutions and high-load applications. Developers choose .NET for many reasons. It runs cross-platform on Windows, Linux, and Mac OS, with enterprise-grade security and high performance. The rich ecosystem includes NuGet, Azure, and ML.NET, while automatic memory management makes development easier. It supports multiple languages like C#, F#, and VB.NET, and is backed by Microsoft and a strong global community. .NET is a complete development ecosystem. It includes the CLR, CTS, CLS base, and framework class libraries, assemblies, garbage collection, NuGet, built-in security, and powerful performance optimizations. Together, these help developers build fast, secure, cross-platform applications for any domain. And with every new version, from .NET 6 to .NET 9, the framework continues to become faster, safer, and more developer-friendly. And that's a wrap on this .NET journey. If you enjoyed learning, make sure to smash that like button and subscribe for more tech insights. Turn on the bell so you'll be the first to catch our upcoming tutorials. Thanks for being here. Keep coding, keep growing, and I'll see you in the next video.